Hello everyone, it's me Rachit back here in another new video. In this video, we're going to be talking about the third disrupting technology, quantum computing. Quantum computing is very interesting, guys, and I saw other quantum computing videos on YouTube, and they're very hard and difficult to understand. But this video, I'm going to explain it very easily, very simple, that even like a 5-year-old can understand this. Okay, so let's get on to it. Okay, so before we get started on to how quantum computer works, we need to know what is quantum computing. So, unlike our normal devices like our laptop, like our phones, like our iPads, like our tabs and everything, these are all called classical computers. They just work normally like any other classical computer. But quantum computers, they use the principles of quantum physics to perform calculations at very high speeds. Our classical computers are not perfect yet. They there are very complex problems, and they couldn't solve those. They take 10,000 and million years to solve it. But the quantum computing, it can solve it in like less than a second. So that's the power of the quantum computers. They work very fast. So let's understand quantum computing. So the definition, quantum computing, as I already told, what is the definition? So the role of quantum physics. So as I said, the quantum physics, quantum computing uses the principles of quantum physics to work, as I said, right? So what is the role of the quantum physics? So in quantum physics, there are two things: superposition and entanglement. So the quantum computing, it uses superposition and entanglement to work. So quantum physics includes the superposition and entanglement, and quantum computing uses these both to work very fast and very accurate. So classical versus quantum. So as I said, our normal classical computers, they use binary bits, zeros and ones. I'll tell you what are bits just in a bit. So quantum computing, it uses qubits. So qubits are called quantum bits. So now let's compare these both. So what are bits and quantum bits, or also you can call them qubits. So bits versus qubits. So what are bits? So you're watching this video on a classical computer. It can be a phone, your laptop, your tab, or your iPad, or anything, right? So they're all classical computers. So they're storing all of this information in bits. Bits can be of two types: 0 or 1. So think of a light switch. 0 is off and 1 is on. So bits, they store all of your information, like your videos, pictures, games, apps and everything, in bits. They store it in a combination of bits, like 0 0 1 0 0 1 0, like that. They store all of your information in a combination of bits. So bits, there can either be a 0 or a 1, not both at the same time. Qubits, they just work like bits. It can be a 0 or 1, but the magic where it comes is qubits can be 0 and a 1 at the same time. So why is this important? Why is this making the qubits and quantum computers more more powerful? It's because both of the bits 0 and 1 at the same time. Because of this, it can explore more possibilities at once. So it can run very very fast, instead of just being 0 or 1. It can be both. So it can explore many possibilities, and it can be at very high speeds and accurate and efficient as well. So yeah, classical computers use bits and quantum computers use qubits. And this phenomenon, this property of qubits can be a 0 or a 1 at the same time, this property is called as superposition. I'm going to explain everything now. So superposition and entanglement. In the start, 1 second, not here. So here I told superposition and entanglement, right? So I'm pretty sure you guys remember what I told here. So now I'm going to be explaining them. What is superposition, what is entanglement, and how these both work together so that it can get all that power for the quantum computer. So let's get on. So superposition and entanglement. So superposition, it's a principle which allows qubits to exist at 0 or 1 at the same time, so they can explore more possibilities, they can work together more fast, accurate, and more efficiently. As more qubits are added to a quantum computer, the more fast it becomes. So basically, yeah, qubits existing at 0 and 1 at the same time means superposition. That property, that phenomenon is called as superposition. So entanglement. So what is entanglement? So qubits, right? As I told, two qubits are connected to each other, so they can pass information and pass information fast and accurately. I'll give you an example so you can understand this properly. Imagine there are two twins, one is on Earth and one is on Mars, and the one on Earth is smiling, then automatically the one on Mars is also smiling. It's because these both twins are entangled. These are magical twins which are entangled. So yeah, qubits, they're also entangled, so they can pass information fastly. So if one qubit changes, like one data is changed, then the other qubit is also changed, so they can like instantly pass that information, so no lag or anything can cause. So these both work together, superposition and entanglement. These both properties of quantum physics work together and they create combined power. So when they work together, that's how they create the quantum computer very powerful and fast. So yeah, it's very amazing. It's a very deep topic as well. So now, easy examples of quantum computing. These are two examples. So yeah, the coin toss example. So when you flip a coin, it can be heads or a tails at the same time until it's catched. So this is how the qubits actually work. It can be the same zeros or ones until it's catched, but in coin toss it's heads or tails. So quantum search. So what is quantum search? This is a very good one. I'm gonna explain it with the 8-box analogy. So guys, this is the 8-box analogy. So this is a very famous analogy to explain quantum search, or generally to explain how fast quantum computing is. So there are 8 boxes, okay? So now one of them has a treasure chest. The 7th box has a treasure chest. Let's just think the 7th box has a treasure chest. If we ask the classical computer to find the treasure chest, it's gonna manually check one by one, like 1, no, it's not there, 2 is not there, 3 is not there, 4 is not there, 5 is not there, 6 is not there. Oh, it found the 7th. So classical computer goes one by one manually to check all the boxes, which is very slow, right? But I'll tell you how quantum computer finds the treasure chest within a millisecond. It doesn't go manually one by one. It automatically searches every single one because of the superposition, because of qubits, because qubits can exist at two positions at the same time, superposition. So that's why, because it can exist as at the same time, it can explore many possibilities, it can explore many outcomes. So these are the possibilities, right? So it can explore all of them at once. So that's the power of qubits and quantum computers. It's very fast. So yeah, hopefully you understood now how fast the quantum computers are actually now. So moving on, the Google's quantum computer. So yeah, Google has created a new quantum computer. I just want to share this in because it's a new landmark. So Sycamore, it's called the Sycamore. So it's a Sycamore processor. It's the name of the quantum computer and the new technology, Sycamore, and the landmark achievement. So the Sycamore, it performed to solve a very complex problem in under 200 seconds, which a supercomputer, not even a classical computer, a supercomputer takes 10,000 years to solve. So yeah, that is amazing. Google's advancements. So yeah, Google has made many advancements in the quantum computing field. The new Sycamore processor, there's a new technology in the quantum computing. So yeah, this is the Google's quantum computer. Even IBM also created a quantum computer, but the Google has recently created it. So I just want to share this in. So moving on, we have the real life applications of quantum computing. So why do we need to know all this, right? Without even applying it in real life. So these are 4 real life applications. So I'm gonna teach them what they all mean. Okay, so real life applications of quantum computing. So there are 4 real life applications of quantum computing: cryptography, drug discovery, optimization problems, and artificial intelligence. So cryptography. So we all have passwords for our bank, emails and everything, right? We have password for every private thing we have. So these are all generated is these encryption codes. Encryption codes are basically passwords, and these are all created by classical computers. But quantum computers can easily crack those codes. They can easily hack into our accounts. So that's what big companies and scientists are trying to do. They're taking advantage of quantum computing so that they can create more stronger passwords. Classical computers create, good passwords, but they're not as strong as compared to what quantum computers can create. Quantum computers create more powerful, more stronger passwords, and they have more, and it upgrades and increases the security around your password so that nobody can hack into it. So yeah, basically cryptography is using quantum computers to make much more better security and much more better passwords as well. Drug discovery. Normally, drugs are not those kind of drugs. Drugs can be medicine as well. When we are sick, we use medicine, we take medicine, right? So we can get better. Those are also drugs. Medicines are also called as drugs. So drug discovery, I'll just say medicine discovery because it will be easier. So medicine discovery. So normally scientists explore in the lab. Basically what they do is they test how the medicine works. Is it working properly in the body and everything? They test it in the lab, which takes many years, which has many complications and everything. So we can use quantum computers to simulate that exact drug testing which is done in the lab in the quantum computer, so it can be much easier and faster. So yeah, optimization problems. So many industries such as Amazon, Flipkart and everything, they deliver you packages, couriers and all, right? So these industries, these have delivery trucks and everything. So basically optimization problems. Quantum computing finds the best ways, the best route, the best area to go through so you can immediately get your package, so that we don't need to waste time. Fuel can be saved, time can be saved and everything. We don't need to go into wrong paths and everything. So quantum computers checks all the paths and everything, so it can be much faster and efficient. Artificial intelligence. So I'll explain artificial intelligence. So artificial intelligence. So artificial intelligence is something called machine learning. So machine learning is artificial intelligence is a machine, okay? AI is a machine which learns from certain information or data, and it builds its intelligence and everything. So normal computer gives it limited data and it helps artificial intelligence learn. But quantum computers, they instantly make it learn. It doesn't need to take that much time. They instantly just feed all the information to the artificial AI. So I'll give you an example for this to make it very easy. So imagine a child, okay? A child, he is a student. He is learning new stuff from the school, and let's say the computers are helping him. So the AI is the child, okay? The child is the AI basically. So that child, the student, is learning from the computer, the normal classical computer. It's feeding him normal data, like step by step. He's the classical computer is making the child understand step by step about a certain concept. But quantum computers, it doesn't need to explain it step by step. It has qubits, so it can explain everything at once, superposition and entanglement, everything at once. So the child automatically knows everything. It doesn't need to take that much step by step. It's all manual process, everything, nothing. So yeah, these are 4 fascinating real life applications of quantum computing. So now let's move on to the challenges in quantum computing. There are quite a few challenges, but yeah. So I'll tell you all about this. So error rates. So qubits are very sensitive, which makes them which even small changes, small movements can make them lose information, or they just won't function properly. So yeah, in quantum computing, there are many error rates in the qubits, which is a very big problem. Scalability. For now, we can only insert some qubits into quantum computers. because we can't yet create big quantum computers so that we can insert many qubits. So yeah, we can't scale it a lot. It's a challenge, but in the future we might be able to. So integration with classical systems. So yeah, our classical computers were very different and very versatile from quantum computers. So making them work together is a challenge, and it's like tricky to make them work together. Cost and access. Quantum computers are very expensive to make and maintain. They need special lab conditions. They need like special cooling to actually be proper, and they can function properly. So yeah, it's very expensive. That's why only some scientists and companies have the access to them. So yeah, there are quite some challenges in quantum computing, but in the future I'm sure we can overcome these challenges. Okay guys, thank you everyone for joining me in this session, and hope you all understood about quantum computing, and stay tuned for the next disrupting technology, because it's gonna be even better. Till then, stay tuned. Bye bye.